Our today's video is about the periodic table. A periodic table is a horizontal and vertical arrangement of elements according to atomic numbers. Atomic numbers are, or you can define the atomic number as the total number of protons in the atom of any particular element. Protons are always positively charged and they will always be equal to the number of electrons. That means if you've been given the number of protons of a particular element, you definitely know the number of electrons that it will consequently have. So a periodic table will have a specific pattern and an arrangement, and this particular pattern gives an impression of a table that has three sections. These three sections, we have the first section that begins from this particular place. We have another section that is painted blue, and we have another portion that is painted green. The first portion at this particular end is what we call them, they are metals. They are simply metals, or rather you can call them S and P elements. The block that is blue in color has got elements that are not normally studied frequently. Only a few are studied, and it is called transition elements. A few example is copper, another example is iron, another example is chromium, another example that we look at is manganese. The other elements are on this side of the periodic table, and mostly apart from this particular group here are non-metals. So generally that's how a periodic table looks like. A periodic table will have the horizontal columns, it will have the horizontal rows and the vertical columns. The horizontal ones running from this end to this end are called periods, and the vertical ones running from top to bottom are called rows. And these particular rows or columns, they give the names to which elements belong. The groups are normally counted from this particular direction going all the way across, and as you can see, we can count our group 1 from this particular point and end at this particular point, so we can count 8 of them. For the periods, we can also count from this top particular point here and go downwards until the bottom, meaning we can count at least 7 periods that we have. So the periods and groups group our element. In the groups, every element that has the same number of electrons in the outermost energy level will belong to the same group. In the period, they'll have elements that have the same number of energy levels. For example, when we talk about group 3, group 3 is this group at this particular point. The group 3 elements will have 3 energy levels, all of them across. If we come to group 4, this is group 4, they will have 4 energy levels, and these energy levels are obtained when you write the electron configuration. For the groups, in the groups we normally have elements which have the same number of electrons in the outermost energy level. If you have 3 elements that have 1 electron in their outermost energy level, you're going to call them group 1 elements. If you have 2 electrons in the outermost energy level, you're going to call them group 2 elements. And that's the most vivid description of this particular description of a periodic table. Now, a periodic table has various characteristics that defines them, and these characteristics are normally defined because of how the arrangement is given in a particular table. It gives a characteristic of all the elements and the general trend that must always be understood at every particular time. And this is a general statement that you need to know, that in all the elements that we'll have amongst all the periods, across all the periods, the atomic radius will decrease, ionization energy will increase, electron affinity will increase. For all the groups, the general trend is atomic radius increases, ionization energy decreases, electron affinity decreases. So all these elements, they normally have a specific trend according to these 3 particular specific terms: atomic radius, ionization energy, electron affinity. And also you need to notice how they either increase or decrease. And these changes or these particular trends are normally caused specifically by certain factors. And before we do that, we need to understand how do we define the terms electron affinity, ionization energy, and even atomic radius. I'm going to begin with the term electron affinity. Electron affinity means the amount of energy change when an electron is added to an atom. And this is the short, that the energy has to change. The energy has to change. Now, we are talking of an energy involved when an electron is added to an atom. That means for these particular atoms, they must be gaining an electron. And to go back to our periodic table, there are specific atoms that will readily gain their electrons, and those atoms begin from this particular position going towards this direction. They can easily gain more than they can lose. So when you talk about electron affinity, it's important that we give emphasis to these elements, especially those that are in group 5, 6, and 7. They can easily gain their electron, and they can hardly lose their electrons. For that reason, these elements are said to be very electronegative. And for them being very electronegative, they also have very high electron affinity. And electron affinity, you can imagine it as being elements that can easily gain, they can easily they can easily gain electrons. They really love to have electrons around them. For these other elements that are in this particular section, especially group 1 and 2 and also 3, they have a term that describes them, which is not electron affinity, and that term is what we call ionization energy. Ionization energy is the minimum amount of energy required to remove an electron in its gaseous state. Group 1 and 2 elements will always lose their electrons to become stable. And when we talk about lose, we are talking about this one, which only has a single O. So they will lose their electrons, and the reason as to why elements lose or gain electrons is to become stable. So if we go back to our table and we look at what ionization energy entails, it involves the elements that are in group 1 and 2. We have our group 1, and you have our group 2 following. They follow each other in that direction. These ones will have, or they will exhibit, ionization energy. Ionization energy is the energy required to remove an electron from its outermost energy level. Remember that electrons are negatively charged and protons are positively charged, meaning in an atom, the number of protons being equal to the number of electrons, they will always attract. And for you to remove one electron from that particular energy level, you'll require energy. And that means if you need a lot of energy to remove an electron, it means that the particular atom will be less reactive. Remember, we said that for electronegative elements, they normally gain, and for these that normally lose, they are said to be electropositive. They can gain, they can lose and lose and lose and lose. We can look at an example of how to group our atoms in the periodic table. Here we have various cases of 3 elements that we are going to use. The first one is sodium. Sodium has 11 protons, and because it has 11 protons, it also has 11 electrons. The electron configuration therefore will be 2:8:1. So it will have 3 energy levels, 2 and 8 and 1, meaning it is in period 3. And because the outermost electron energy level has 1 electron, it means it will be in group 1. So sodium is in group 1, period 3. Potassium, on the other hand, has 4 energy levels because of the electron configuration 2:8:8:1. It has 1 electron in the outermost energy level, and therefore it will be in period 4 and group 1. That means that sodium and potassium are in the same group but in different periods. Next time we are going to look at the chemical families.